Dear students, welcome to the problem solving session of area as double integrals. In our previous session, we learned the basics on double integral, how to evaluate double integral when the limits are constant and the inner limits are variable. And we start to change the order. When x is variable, we change the order as y is variable and vice versa, and we solve the problem. In today's session, we are going to find the area using double integrals. The formula for finding area is simply double integral dy dx over the region R, that is equal to double integral over the region R dx dy. So according to the question, we can fix either y as variable or x as variable, whichever it is easy and compact for us. Case 1. If I am taking the region bound by y curve, that means my x is constant, x equal to a to b. In this case, my y is the variable. I will use the vertical strip. Do you remember, student? Which goes from bottom to top. Region bounded by y curves, y is going to be variable. So dy dx. Let us have a quick recap on basic. If I draw the line x equal to a and x equal to b, then y equal to sum f1 of x and f2 of x, then the region bounded is going to be this region. Suppose you are fixing region bounded by x curve. In this case, y is going to be constant, y equal to c to d. My area is simply double integral over the region dx dy. Here x is the variable, so we use horizontal strips which moves from left to right. We can see the diagram and we can move the strip from left to right, which covers the whole region. Yeah, with this idea, we are going to solve the problem. Therefore, the formula for area is simple, double integral over R. Either you take dy dx or you take dx dy according to your convenience. Let us go into the problem. Find the area of circle. Yeah, this circle is very easy for us. By seeing the circle, I can say the center is 0, 0, radius is a. So my step 1 is writing the equation and information which is needed to find the area. So the circle is x square plus y square equal to a square, center 0, 0. Now if you take this axis like a, 0, 0, a, minus a, 0, and 0, minus a. So I'm just writing the point. Step 2, we have to draw the figure. Now I want to find the area of this circle. So it involves all the 4 quadrants. So I have to shade everything. But what is the trouble now? If I want to take a vertical strip, it moves from here to here. Do you understand? If I want to take a horizontal strip similarly, then also it will move from left to right. So what is the issue here? This quadrant x and y are positive. And when you go for this, x is negative, y is positive. Here x is negative, y is negative. And x is positive, y is negative. So it is very tough for us to choose the limit. Suppose I'm taking the vertical strip, x square plus y square is equal to a square is my circle. In the first quadrant, the y will be positive square root of a square minus x square. But when you go to this place, in the fourth quadrant, y is negative. So I have to take y is equal to minus square root of a square minus x square. So non-math student, just listen. This comes from this equation. Okay, I'm writing like y square equal to a square minus x square and y is equal to plus or minus square root of a square minus x square. At first quadrant, all are positive. I'm taking plus. In fourth quadrant, y is negative. See here, y is negative. So I'm taking the minus value. But this will trouble me a lot. Okay. All these things are for your understanding, students. Just see, it is always better to choose the first quadrant. If I choose the first quadrant, then area I can say it as 4 times the first quadrant, because in first quadrant all the values are positive. So now I can draw the strip like this. Now it is easy for me. Okay. Whenever the area comes, if it is possible for the standard curves, try to make it as first quadrant and find the solution. Now step 3, it's going to be the limits. I am taking the vertical strip which goes from bottom to top. Therefore, see this bottom. The equation is y equal to 0, and when it touches the circle, the equation is y square plus x square equal to a square. So I will write y equal to positive square root of a square minus x square. Therefore, my limits are y equal to 0 to square root of a square minus x square. Now, x limit. The minimum value of x is 0 and the maximum value it covers in the first quadrant according to this problem is a. So the x limits are from 0 to a. Now we are in the final step. Area. the formula for area, since I'm taking the vertical strip dy dx. Now I'm converting the problem into a single quadrant. So area is going to be 4 times the first quadrant. So now it's time to substitute the limits. We can see y limits is 0 to square root of a square minus x square. X limit is 0 to a. Substituting this, we get this format. Now if we integrate, we can find the area of the circle. Just integrate this, we'll be getting like this. Do you remember, student, the integral square root of a square minus x square dx is x by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a. Now we want to substitute the upper and lower limit. When you substitute the upper limit, here you can see a square minus a square will become 0. When you substitute the lower limit, here x is there. So 0 into anything is 0. In both the cases, this term is getting 0. So my area is going to be 4 times a square by 2. We know that sine inverse of 0 is 0 and sine inverse of 1 is 90 degree. So I can write sine inverse of a by a. It's going to be sine inverse of 1. Therefore, my area is going to be 4 times a square by 2 into pi by 2. So 4 get cancelled. We'll be getting pi a square. How easy it is. That's it, students. So we found the area of circle is pi a square, provided the circle with center 0, 0, radius a. Done. In the similar way, find the area of the ellipse. Now we know the equation of ellipse. So when you put x0, the point is going to be 0, b. When you put y0, you'll be getting the point a, 0. Now we know this, the ellipse passes through the center 0, 0. When I put x equal to 0 in this equation, I'll be getting the y points as plus or minus b. Now when I substitute y equal to 0 here, my points are plus or minus a. Done. We know the center, we know the point. Step 2, let us draw the figure. This is my ellipse and this is my complete area. As well as I said in the previous problem, if I choose y strip or x strip, it's very tough because I will get one upper limit as well as one lower limit. It's very tough for me to substitute and simplify. So you see, ellipse is symmetrical about both the x-axis as well as the y-axis. Now I can take the region. Now I can take only the first quadrant. If I take first quadrant, I can avoid like two limits. I can simply take this as 0 to b if I draw the vertical strip. And again, I'm telling you, students, you need not to be draw vertical strip always. Just I'm doing. You can go for the horizontal strip also. Now we can fix the limits. Since we have a vertical strip, it goes from bottom to top. My y limits are 0 to y is equal to square root of. The limits are going to be, since we are using vertical strip, it moves from bottom to top. The y limits are 0 to y equal to b into square root of 1 minus x square by a square. Hope you understand, students, how this comes. See here, take this equation. Y square by b square is equal to 1 minus x square by a square. Now if I take square root on both sides, we'll be getting y by b. I will push this b to the other side. 1 minus x square by a square. Next, x limits. X limits are going to be very easy because in the first quadrant, the starting value is 0 and the end value is a when it covers this region. So it is going to be simply x equal to 0 to a. It's just similar to the previous problem, guys. There we have circle. Everywhere we have the length is a, the radius is a. Here ellipse we have major and minor axis a and b. Next, the formula for area is double integral over dy dx, but we are choosing the first quadrant. So I am writing 4 times integral 0 to a and integral 0 to b by a square root of a square minus x square. Now as usual, we have to integrate this, student. It just ditto of the previous problem. Now apply the formulae. As usual, either you apply upper limit or lower limit. This becomes 0. So I have 4b by a or my. Next we are going to do the integration. So now 4 times integral 0 to a. When I integrate dy, I will be getting y b by a square root of a square minus x square dx. Lower limit is 0. Upper limit, if I substitute, I will be getting 4b by a. So lower limit is going to be 0. When I substitute the upper limit, we'll be getting b by a. Since b by a is constant, I can take this out. So we'll be getting 4b by a integral 0 to a square root of a square minus x square dx. Now, as usual, use this formula. and we can find both upper and lower limit of 0 for the first one, and then a square by 2 sine inverse of a by a, upper limit. Lower limit is 0. So it is going to be 90 degrees sine inverse of 1. So I have to write in radian pi by 2. Now a get cancelled, 2 get cancelled with 4. Therefore my area of ellipse is pi AB.
Thank you for watching. We hope you found this video helpful. Stay tuned for more and keep up the great work. Subscribe to our channel and see you in the next video. Bye bye.